Hello friends, good evening. Welcome back to our channel ALP Talks. This is your Lakshmipati. So today we are here with one of the good topic, lighting design. This lighting is one of the important aspect because everyone knows that there are different concepts because in the normal our house itself will go if any lamp burn out or if fuse goes out, our lamp is not working, we will simply go to the shop and we'll first check the price. Right nowadays some people may be checking led lights, but and most of the people will check about the price. So in earlier days we are using incandescent bulbs, right? I mean the bulbs with fuses what the Edison first invented. Some I also remember we used it to get by for 10 rupees the lamps and all. So nowadays the everything is changed. So the system becoming complex. The appearance also matters. The uniform distribution also matters, and cost also matters, and energy savings. I mean, if you are using for say for example 1 or 2 years, how much energy, how much power it will consume during its lifetime. So that also matters a lot. So those things we are going to cover in this today's video. Yeah, I hope you will enjoy this content. Yeah, before going to the topic, if you're watching this video for the first time, then please subscribe to this channel so that whenever I'm uploading videos, you will get a notification so that you can click on it and you can watch it. Yeah, so let's go to the topic. Yes, lighting design. So here is so there are some what, who, and why. So whether it is a indoor or outdoor or commercial application or industrial or residential areas or lighting or whatever the area, lighting plays an important role, crucial role. So lighting designers, they can be electrical engineers, manufacturing agents, or facility operators, interior designers, or electricians, or architects, owners, and end users all are involved in lighting design process. So lighting design is a combination of applied art and science. So it is essential to have theoretical as well as a practical point of view in designing lighting systems. So it is possible to have different solutions for the same lighting problem. Yes, of course, that facility is there. So where does it start? Where does it start? So gathering of requirements first. Initially, we should gather the requirements. So area dimensions, the lux level requirement, reflectance, and daylight availability, age of occupants, and lighting control methods. So types of fixtures consideration, maintenance, and cost factor finally. Initial cost, operating cost, and maintaining cost, etc. So these things we should take care. There should be clarity before embarking on design process. For example, particular make of fixture to be selected or deselected. Those things we should keep in mind based on our past experience or the industry trend. So in industrial applications, particular lighting requirements need to be communicated before start of lighting design. Example, boiler lighting, lighting around crane, something they can, these things needs to be communicated before starting the process. So here you can see the flow chart. So what this flow chart says, this is complete lighting design procedure. So whoever the lighting designer is there, so the building program, there will be one program how that in which manner we are going to take care all the things. So here task analysis. So the difficulty, time factor, type occupant or worker, cost of errors, special requirements. So these things we have to check once, and then preliminary design starts. General, local, supplementary. It's choice of sources and choice of system, architectural, lighting elements, daylighting, ambience, etc. So these are the some preliminary design. And if you come to the detailed design, there comes as a fixture ceiling system and a degree of non-uniformity, fixed or movable lighting. So these are the some of the detailed design, and we need to perform some detailed calculations also. Contrast or ESI or VCP, luminance ratios, maintenance of other factors. Yeah, so we have evaluation. Finally, we should evaluate it, energy usage, cost, constraints, operations. So some of the things we should evaluate it. And finally, the final evaluation is the most important thing. We should take care that final evaluation and cost figures and the projections and building energy. Those are the some of the terms we should yeah, consider while evaluation. So we will say HVAC design also comes in the preliminary design. So we have a owner or it can be user also. We have architecture. So everything cost framework also matters a lot. And we have some energy budget for this building. What is the energy budget? How much is the allocated? That also we should keep in mind while going to this. There are some jurisdictional constraints also. I mean, from the building codes or legislation or government agencies or sometimes the local authorities are from courts. Yeah, we should take care of those things also into the implementation. Yeah, so those things also needs to be taken care. Yeah, so types of lighting fixtures. So there are different types of lighting fixtures. So I mentioned four numbers here. For example, incandescent we have halogen. Similarly, we have MV, HP and LP, SV, HP and LP, MH and a fluorescent. So we have LED lighting and induction lamp also we have. So here you can see lamp type, different types of lamps are available and the range also. I mean, what is the wattage range for these lamps? For example, if it is a CFL lamp, 18 watts to 36 watts, and we have fluorescent lamp T5, T8 and T12, and similarly halogen lamp 50 watt and metal halide 70 watts to 250 watt, high pressure sodium vapor, low pressure sodium vapor, and induction lamp. Finally, we have LED lamp. That is not the least, but that is most important one in this today's world. So you have luminous lux also. How much lux we need? You can see it here. So different values of lux is mentioned here. The efficacy also that also most matters here. So almost CFL and the lamps are 60 to 80% are better. And you have here is you can see low pressure sodium vapor that is 100 to 230% efficacy values. And average life also you can observe here. Generally, the induction lamp is almost 1 lakh hours the life efficiency. LED will be almost 80,000, depending on a little bit lower values. And we have color rendering also. What is the color rendering for each lamp? Here you can see for the CFL you have 75 to 85%. For a fluorescent you have 80 to 90, 80 to 85, 50 to 75%. Similarly, for other races, other things also you can observe here in this table. And one more thing you have to keep in mind is so types of indoor lighting fixtures. So that mainly as per light function only. So ambient. So why we will use general lighting, task. Sometimes a directional lighting, we will give some directional lighting. Sometimes we will use accent. Directional lighting to create visual interest, just to create some a little bit interest, we have to use different time. And informational lighting or guidance lighting, there are some information, for example, signboards or some company names or some other photos or some otherwise daily important routines or something. Those are informational lighting. And another thing is decorative lighting. So decorative lighting also plays a major role. So what are the different types of things we have to consider? So these are the main things. So if we come to the types of indoor lighting fixtures, so the mainly as per installation method, how we are going to install it, there are different varieties available for us. So you can see it here: recessed lights, down lights, trophers, or cove lights, and surface mounted lights. You have pendant lights, high bay, medium bay, and medium bay, low bay, and direct, semi direct, general diffuse, and semi indirect and indirect. These are the based on the installation also. Yeah, so here you can see types of outdoor lighting fixtures. So outdoor lighting, we will first get the word of naming of outdoor with the sense, mainly the sports complexes, streets, floodlights, sports lighting, and streets and roadways and pathways, parking lots also, garages, sometimes the security and some landscape and there are some engaged lights also. These are the different areas or applications we can say. So LED lights are major advantages over others. So because why? Because longevity is high, energy savings, flexibility, brightness is good, no mercury, no UV radiation, available in a huge variety. These are safe to use. They are very safe to use. You can see it here. The capacities also. Light emitting diode. All things are based on wattage comparison chart from one light to the other light. You can observe these things. So we have lighting accessories. For example, sockets, outlets, plugs, lamp holders, types of switches, tumbler surface, flush switch, pull switch, and rotary snap switch, and push button switch, junction box. These are the some of the items we should consider while designing lighting system. So lighting distribution. So there are some distribution boards also like lighting dB, main lighting dB, sub lighting dB. So there are the dBs also 6-way, 12-way, 8-way, and emergency supply also will be there. And cabling is one of the main thing. And voltage drop of cabling also we have to take care. Finally, bill of material we have to prepare with a detailed manner so that this can be sent for the procurement. So how we will control the lighting? We have dimmer. We can use the dimmers for controlling the lights and controlling the input power for the luminary. For example, dimmer can be resistant type or salt water type or transformer dimmer or electronic dimmer such as thyristor or triac or anything. We can have on or off control. For example, one lamp controlled by one switch, two-way and off switch, and a staircase lighting. These are some of the flow graphs or flow charts for that. And photo sensor dimming. For example, when daylight is present in sufficient quantities to serve as primary source of light for a space or area, and control of electric lighting system should be unnoticeable. Occupancy control. For example, whether the persons were there or not, whether they occupied or not. So when space is occupied and accordingly automatically they will on the lights when it is occupied. When it is unoccupied, they will switch off the lights. So they can use some sensors suited to smaller and enclosed space that are intermittently occupied, such as private offices, classrooms, conferences. We have some rooms, coffee break rooms, restrooms, and other spaces. So we can use these the occupancy sensors. The most common single technology method are passive infrared PIR, we will say. Similarly, ultrasonic, we will say US. And we have dual technology DT sensors that will combine PIR with the ultrasonic or with the acoustic sensing. There are some other methods also, include microwave sensors, which emit low power microwaves and detect changes in occupancy, camera based sensors also. Yeah. So time control also. We can control the time, how much time it should on, how much time it should off. We have color tuning also, what colors you need, red, green, blue. These are the main colors. But we can mix by using some technology, mixing technology. Mainly these things are most useful in cinema stage decorations or some functions stage decorations where dances and everything is there. So, and one more thing is a centralized intelligent network control system. So everything we should bring down to the send one particular system so that we can discuss from there itself. Yeah. So here you can see absorption, brightness. Yeah. So these are some important terms we will use in the lighting design. Luminous flux, luminous intensity, cutoff angle, CRI, CCT. Glare also plays a major role. Direct glare, discomfort glare, reflected glare, disability glare. We can have radiance and a spectral radiance. So reflection, refraction, transmission, interference. These are the some of the pictures, some of the things we have to take care. There is one isolux chart, a series of lines plotted on any appropriate set of coordinates. Each line connecting all the points and surface having same illumination. So, for example, lightweight, the percentage of reflected will be 81%. If it is a light cream, 69 to 75%. Light green, almost 65%, it will be reflected. So, these are the different colors you can see. Yeah. So, lighting calculation method, how we can calculate the lighting? What are the different types of available methods for us? So, you can see it here, journal cavity method and point by point method. We have these two different varieties. This is the formula we will use for calculating number of luminaries. Here, EA by MF into UF and phi n. So, this is the formula we will use here. E is the maintained luminance lux, how much is required, number of lamps in a luminaire, and the maintenance factor, sometimes light loss factor we will say, utilization factor, and area of room which plays a major role. These are the things we have to take care. So this is the LT panel. So for example, Havells Magnum Grand. So for 4 number of 42 watt we can use for getting 5700 lux. We can use the 22 pieces for eliminating this one. Yeah. So this is another way of representing the same application. So here you have street lighting design. So street light design, how we can do types of road, street light pole, and lighting fixture, lighting factors, and lighting uniformity, lighting pollution. These are some of the factors we have to take care in the street light design. So here you can see elevation of a street light pole. This is the street light pole. What is the height of the pole, and what is the boom length L, and what is the tilting angle, and the mounting height of fixture. So outreach also matters a lot, and width of the road also matters. So these are some of the things that we should consider in the street light design. So street light classification and required flux level. Here we kept like different groups terminology. For example, here you can have different illumination levels, group A1, group A2, group B1, group B2. That is the classification road and type of road, important traffic road based on the traffic. If it is a high traffic means the consideration is different, low traffic means consideration different. If it is a city normal streets, their consideration different. And because illumination lux levels are different completely. If very high traffic means better light is required, so we will say better illumination, most say 30 lux for example. So these are the different values. And height of poles, and based on height of pole also we have to consider here. For example, 6 meter poles we will use for streets, alleys, and public gardens and parking lots. So somewhere we will use this 6 meter. And 8 meter also we will use in urban traffic route, multiplicity of road junctions. And so like that we have 10 meter, 12 meter, and 18 meter also. These are the different height of the pole, and for which application we will use. So here you can see emergency lighting, because at any case emergency lighting should be there even though the power failure is there. From the battery backup, the emergency light, everything should be turned on. Otherwise it is very blast, right? I mean, it is of no use. If you are in some very dark place, you don't know where to go, then it is very danger, right? So at least the emergency lights, final exit, exit signs, direction change, or intersections or something. So those are the high risk areas. So this emergency lighting also plays a major role. So those we should consider. So we should give some separate focus for these things. Yeah. So finally, economy also matters a lot. So a comprehensive economic analysis of a proposed design will consider variety of different economic concerns, such as comparison of alternative systems or components, the benefits provided by lighting system or component relative to its cost. So evaluation of maintenance techniques and procedures, evaluation of energy management technologies and strategies, impact of lighting on other building systems, associated cost, and the project's budget constraints. So we can't consider everything, we can't keep everything, and we can't consider all the types of lights available, because the use may be very limited, right? So based on the urgency, based on the importance, based on the use, the value it is providing to us back, it is providing back to us, where the money value, that also matters a lot. So those things we should take care. So there are some latest trends in the lightning, such as IoT. So IoT also we are using smart lighting uses wireless switches, eliminating the need to wire light switches directly to fixtures. Those bulbs are then connected to a network, allowing to monitor from the cloud, mobile or app or system. You can manage it, and if any broken or anything damage is there, then you can directly visualize everything. And these are the some for example, asset tracking also possible, monitor conditions for perishable goods, and space utilization also we can consider it. And Li-Fi is one of the visible light communication system, transmitting wireless internet communications at very high speeds. The technology makes a LED light bulb emit pulses of light that are undetectable to the human eye, and within those emitted pulses, data can travel and receive. So this is one of the Li-Fi technology. So it is similar to the Wi-Fi. Yeah. So these are the different standards available for us. For example, Illumination Engineering Society is there. Indian standard 3646 is there for different interior practice. And I in the international standard IEC also there 62504. You can refer it for general lighting, LEDs and modules and all. National we have NLC also, National Lighting Code, and we have IS 6665 code for practice of industrial lighting. Similarly, we have IEC 60598 for particular requirements, luminaries for roads and street lightings. So this is about the lighting design, friends. I hope the content is informative to you. It is useful to you. Yeah. Thank you. Thanks for watching. If you're watching the video for the first time, then please subscribe to this channel so that whenever I am uploading videos, you will get notifications. Yeah. Thank you, friends. The source for this presentation is from Mandar. So he is one of our presenter also in our last sessions. He presented very well. Yeah, thank you, Mandar, for providing a very good presentation to us. And thank you, guys. We will meet in next video. Bye. Thank you.